now today we are going for a very beautiful concept, and that concept is uh, operator precedence parsing. So let us try to understand concept of operator precedence parsing. Okay, operator precedence parsing. Okay, what we need to understand here, what we need to understand here is that if we have a production which is of the form E implies E plus E or E star E or A. If we have a production of the form and this production gives me input string as say A plus A star A. Okay, so if we start building this start building operator start building a pass tree on this, this will give me two representations. Okay, so it will be something like a then star a. This is one pass tree representation. Another pass tree representation could be like a then star a a. Okay, so this gives us an understanding that uh, the ambiguity exists. Okay, this gives us understanding that ambiguity is a big issue. So means ambiguity need to be resolved. So means what, if you have a grammar if you have a grammar which gives generates more than two positive, this is going to be an ambiguous grammar. So the ambiguity exists. So in order to handle this ambiguity, and ambiguity exists because we haven't determined the precedence of the parsing. Okay, now if you look at the precedence of operator, what we have. Okay, if you look at precedence, right? If we define a precedence, what we have DMAS, or we can see BODMAS. Okay, so I think you have learned, we have learned this into our school days, that DMAS is division, multiplication, addition, subtraction. BODMAS is bracket of division, multiplication, addition, and subtraction. So DMAS and BODMAS. These are what? These are particularly for determining precedence of operator. Precedence of operator, and the precedence of operators are being determined using DMAS and BODMAS. Okay, so but like if at all in case of parsing, how we are going to handle this? This is really interesting, and operator precedence parsing is a solution to this. So this will handle this particular. This is the only parsing method which handles the ambiguity uh, and solve all your problem related to the mathematical expressions, whatever you define. Okay, so the key pointers which are including to this operator precedence parsing, the key pointers are this is an example of bottom up parsing. Okay, this is an example of bottom up parsing, and this resolves the precedence, the execution precedence of operator, right? This resolves the execution precedence of operator. So means this handles the ambiguity, right? This handles the ambiguity, and this helps us to determine the precedence of execution of operator. Okay, so this is important. This determines the precedence, okay, of an operator. Okay, now in this case, if this is the case, that this is an example of precedence operator bottom up parsing. It resolves the execution precedence of operator, means it handles ambiguity is handled and resolved more properly. Okay, then this determines the precedence of execution of an operator. So this is like, okay, now in order to do this, there are certain requirements. Okay, right, now in order to perform operator precedence parsing, you need operator grammar. Okay, so then ultimately question comes like, what exactly the operator grammar means. See for example, if you have been given a, you have a, if you're given a grammar which is something like, say for example, E implies EAE, or uh, opening bracket E or A, and A is plus or star. Okay, E implies EAE, opening bracket E or A. So this means that if we start substituting A, this grammar can be in this particular form. E implies E. What is A is plus. Okay, what is now E is, if E is substituted as EAE, so which means in further state this could be E implies E plus E star E. Okay, E implies E star E, or in this case, if it is a case, this will give me in substitution as A plus A star A. Okay, but this is giving me this, but okay, the is like this grammar allows me to have this sort of input string. There's no issue, but like, is this grammar is convenient for operator precedence parsing? Now the answer is no. This is not convenient for operator precedence parsing. So this is not convenient. Now question is why, right? So in case of operator, in case of an expression, you know that in case of expressions, when you build an expression, uh, no two terminals are adjacent. So, okay, so which means that I cannot have an expression something like this. If A is an a terminal symbol, no terminals are adjacent. Now, usually you will find the terminal by substitution of non-terminal. So, which means, like, say for example, E is being substituted as A, right? And if it is, say, if it is B, right? If it is B, means A star B. If this is the production, then if this is the production, just a minute. If this is the production, and if A is being substituted as B and A is substituted as E, so means E is substituted as A. So which means when you have E is being substituted as E A E, and this E is substituted as A, this A is substituted as B. Say for example, in this case, what happened? Two terminal becomes adjacent, but now in this case, if two terminals become adjacent, then how you can build an expression? So this is happened because two non-terminals are adjacent. Okay, then in this case, in such a case, if two non-terminals are adjacent here, adjacent, they are placed side by side, then the grammar is not an operator grammar. Okay, so this grammar is not an operator grammar. Why? Reason is like, this will be like, if you start substituting the non-terminals, then two terminals becomes adjacent, and we know that if you want an expression to be built, then two terminals must be separated by operator in order to build an expression. So this is important. Two terminals must be separated by operators. It means that two non-terminals must be separated by an operator. So this is not an operator grammar, right? So if this is the case, this is not an operator grammar. Why? Because here two terminals are non-terminals are adjusted. Okay, adjusting. Okay, adjacent. Okay, and the next most important criteria is this operator grammar must be epsilon free. The grammar must be epsilon free, right? So means if it contains, say for example, epsilon. Okay, so if A is epsilon, right? If A implies epsilon, so it means that if A is implying epsilon, means if you take this here, E is being substituted as EAE, and this A becomes epsilon. So EE and EE. So what is going to happen? E and E, they both are becoming again adjacent. Okay, so EE are becoming adjacent. So means what, if you wanted to have an operator grammar, right? So in case of OPP, that is operator precedence parsing, you need operator grammar. You need operator grammar, right? And the criteria is epsilon free. This must be epsilon free grammar. This is one. Second, no two non-terminals are adjacent. Okay, so have you got these two criteria? So first criteria is operator grammar is epsilon free grammar. No two non-terminals are adjacent. Okay, so if you find a grammar which is something like E implies E A E, or opening bracket E or A implies plus minus star divide, if this is the case, so which means that this will help us to build E implies EAE, right? A is being substituted as, say for example, plus, so E, this E is, say, EAE, right? So you can have this representation something like here, E plus E star E, if this is A plus A star A, right? Though this produces the input string whatever we have expected, but since these two non-terminals are adjacent, this is not an operator grammar. So this is not an operator grammar. Okay, so now what if it is E plus E or E star E or opening bracket E or A? Is this is operator grammar? Check for these two criteria. Epsilon free? Yes, it is epsilon free. No two non-terminals are adjacent. No, that E and E, they are not adjacent altogether here. So this is an operator grammar. So the answer is yes, this is an operator grammar. Okay, yes, this is operator grammar. Yes, this is operator grammar. So you can proceed with this operator grammar. Okay, once you determine, okay, though it is an operator grammar, this we are very sure that this is leading ambiguity, leads ambiguity, but so we need not to worry. No worries here, right? Because we know that this ambiguity is being handled. Okay, now as far as structure is concerned, since it is a bottom of parser, structure is concerned, here structure is same. What you have? You have, this is input stream. Okay, then what you have? You have a parser. This is a parser, right? And what parser has? This is a parser routine. Now this routine is operator precedence parsing routine, right? And this takes the data input string and put it on to what? Here, this is going to be your stack. Don't forget, this is a stack. Okay, and this is input string, and we know that all input strings are being included in the within the dollar itself. Okay, then it has certain actions and all that. So here all the parser routine and parsing table, these are going to be there, right? But here, in addition to this parsing table, you need a operator relation table, right? Okay, you have operation relation table, or you can have a function table which will tells you like, okay, uh, the relationship between the different operators and their moves required, right? So this is operator relation table. Now, okay, so in order to define the relations in operator precedence parsing, uh, the relations are like this. uh, this is this is greater relation, this is lesser relation, this is equal. Okay, greater, lesser, and equal. Okay, so since like we have some key indicators, so we have some, say for example, we have key pointers. What are the key pointers, or thumb rules, right? Thumb rules, right, which you need to keep in mind. Okay, so these relations are particularly defining what? Precedence. This relation are particularly defining precedence. So what are, so this is a greater precedence, this is lesser precedence, this is equal precedence. Okay, now what are the key pointers? Key pointers here are any terminal terminal of type variable, like for example, or small face letters, like in this case a, right? Or we can say identifier, type identifier, are having higher precedence on operators. Right. Okay. Because if we could not, we cannot prepare expression without identifier, right? We can, right, and operators. But identifiers are playing an important role. Identifiers are the values that are being evaluated by the expression. So without identifier, you cannot build an expression, right? Or having only operator cannot be an expression. So it is mixed kind of thing. So identifiers are required and operators are also required. So in that case, all identifiers, since they are carrying the value, they have a highest precedence over operators also. Okay, this is this, and most importantly, dollar. Right? We know that dollar is an input end marker, and it has lowest precedence. It has lowest precedence over all. All means what? All means it has a lowest precedence as far as identifier is concerned and operators are concerned. Okay, so it has a lowest precedence. So this key pointers you need to understand that any identifier that are part of an expression has a highest precedence over operators, and any input symbol, in marker, that is dollar, has lesser precedence. And since like if you look at all operators, they are left associative. Okay, so they are left associative means plus has a greater precedence over plus, star has greater precedence over star. So it is like this, and in this case, star has a greater precedence over plus. Okay, it is like this. So on the case we can say that plus has a lesser precedence over star. Okay, but if you look at, if the both our operators are same, in that case in that case, since they are left associative, the same operator has a greater precedence over the same operator. Okay, it is like this. But if the operators are different, then you can say that star has a greater precedence over the over plus. So which means that plus has lesser precedence over star. So this is the case. So as a part of this, you must understand the basic points which are required for an operator precedence parsing. The basic points is, first you need to see whether the grammar is operator grammar or not. There is a criteria for operator grammar. Operator grammar is epsilon free grammar, and in operator grammar no two adjacent non-terminals exist. Okay, it is epsilon free and no two non-terminals are adjacent here. Okay, so instead, if your grammar needs an ambiguity, still no worries, because operator precedence parsing handles this in a very well way. Okay.